Hi everyone, it's Miss Landis here, and for today's contingency plan lesson, we are doing topic 16, lesson 1, which is lines. Our outline for the lesson is to complete the solve and share, complete the look back. We will be going over the essential question and discussing the important content in the lesson, completing the convince me, and then page 823, numbers 1 through 15. So the title for lesson 16.1 is lines. Our I can statement is I can draw and identify perpendicular, parallel, and intersecting lines. So we will be drawing some of these lines and identifying, so being able to tell them apart and classify these types of lines. I will read the solve and share, and then I will pause it for you to try yourself. The number line below is an example of a line. A line goes on forever in a straight path in two directions. Underline the word straight. Well, underline straight path. That's an important term in defining a line. A line needs to go in a straight path, so it cannot be curved. A line goes on forever in a straight path in two directions. Draw the following pairs of lines. Two lines that will never cross. Two lines that will cross at one point. Two lines that will cross at 2 points. If you cannot draw the lines, tell why. So before you pause, I'm going to help you set this up. Now they tell us to look at this number line as an example. The number line has arrows on the end to show you that it's going to keep going and going. When we're counting numbers, we don't stop at 9. We can continue to count numbers on and on. So if we extended this number line, we would be able to show a tick mark for 10 or 11 or 12. The number line also would continue to go on in this direction. Even though it shows 0, as you get older, you'll see that there are negative numbers as well that can be shown on the number line. So number lines go on and on forever. So we are going to draw different types of lines here. The easiest way, I believe, to complete this solve and share would be to set up a chart. You're asked to do 3 things. To draw 2 lines that will never cross, 2 lines that will cross at 1 point, and 2 lines that cross at 2 points. Or if you cannot draw the lines, tell why. So set up a chart like this to organize your work. We need 2 lines that will never cross, two lines that cross at 2 points, or I'm sorry, 2 lines that cross at 1 point, and then 2 lines that cross at 2 points. So at this point in the video, after you set up your chart, you can pause and try, and then when you're finished trying the solve and share, you can unpause the video to see how I go over it. All right, so welcome back. First, let's draw 2 lines that will never cross. So when we're drawing lines, remember to put your arrows on the end. So I'm going to draw my line just straight up and down. Now, in order for me to draw another line, there has to be 2 lines that will never cross. I need that line to be going in the exact path. That way they would never touch each other. So I'm just going to draw an identical line going in the same direction. And these two lines, they would go on and on in both directions, but they would never touch. Now we need two lines that cross at one point. So all you need to do is draw one line, and you can draw it in any direction. I'll draw mine kind of diagonal. And I just need to draw a line that goes through it in any direction. So here's another line. And here would be that one point where they cross at, right there. And when you see pairs of lines that are intersecting like this, usually the point will be named. So we could call this point R, the point where they're crossing. Now we need two lines that cross at 2 points. However, that can't be done because lines go on forever in a straight path. Looking at these lines, they're going to keep going in their directions. They're never going to cross again. If you peek at the look back, you might have been kind of tricked into drawing something like this, where we see 3 points of crossing, but this is not a line because it's curved, it's not straight. So at this part in the chart, you could write something to explain why you can't draw that. So if you cannot draw the lines, tell why. So I would say lines cannot cross at 2 points because lines go on forever in a straight path. The path cannot be curved. All right, so now let's look at our look back, which kind of goes along with this part in the chart where we say that, you know, this is not a line here. So Terry says the lines shown intersect at 3 points. Well, we do see 3 points where these two cross, but this curved one is not a line. So how can we say that Terry is incorrect? We need to explain. So let's start off with rephrasing. Is Terry correct? No, Terry is incorrect. So Terry is incorrect because although we see the paths crossing, or we can't call this a line. So although we see them crossing, the curved one is not a line. Crossing, comma, the curved one is not a line because the path is not straight. So Terry is incorrect because although we see them crossing, the curved one is not a line because the path is not straight. Something along the lines of that. We cannot call this a line because it's curvy. It's not straight. Although this one right here, that is a line, a straight path that will go on forever without crossing. All right, so let's turn the page and read through the important content in understanding how to classify and draw these lines. Our essential question is, how can you describe pairs of lines? A line is a straight path of points that goes on and on forever in opposite directions. A pair of lines can be described as parallel, perpendicular, or intersecting. There's a picture here that's kind of giving a real world example. So we're looking at railroad tracks, and I don't exactly love this picture because it kind of looks like the railroad tracks are going to touch in the distance. But what we know about railroad tracks is that they don't. They go on in that path that's like this, continued on through, the destination of the railroad tracks and in where the tracks are going. So railroad tracks would be examples of parallel lines, and that's what the bubble says here. The railroad tracks in the picture are parallel because they never meet. The railroad ties are perpendicular to the railroad tracks because they intersect at right angles. So here we can see the railroad ties. Those are what's keeping the tracks down to the boards. Where they would meet at this spot and cross, I'm kind of darkening it with my pen. But we can see the lines that are made here. And we'll read about what perpendicular lines are down in the description in defining them. But that would be a real world example. And in the Convince Me, you are supposed to find different examples. So that's just kind of giving you some clues as to how you can find them in life. And it'll help you more to understand the differences between the pairs of lines. So moving on down to B. Pairs of lines are given special names depending on their relationship. So we have parallel lines. Parallel lines never intersect. We have intersecting lines, which means they pass through the same point. So the point would be here. And then we have perpendicular lines. Perpendicular lines are also intersecting because they do cross, but they're special because perpendicular lines are lines that intersect to form right angles. And right angles have square corners. So see how you can fit a little square into that corner perfectly? That would be perpendicular lines, have that square corner to form a right angle. All right, so the Convince Me, I think, can help us to understand the types of lines better. So find examples in your classroom. Okay, you're not in your classroom, but you're at home. So look around at home and see if you can identify parallel lines, intersecting lines, and perpendicular lines in any place that is in your home. So, take inspiration from what's around you. Look for something maybe that has two edges that would never touch. That would be parallel. Look for intersecting lines as two lines that cross each other. And then for perpendicular lines, you can look for square corners. So one way that you can set this up for examples would be parallel. We need intersecting. And we need perpendicular. And this can be a good one for us to discuss when we're back in our classroom. I can't wait to see the different things that you find around your home. That would be good examples of these. So I wanted to try to pause the video for me to look for examples. I probably should have thought about that before I started making the video, but I'm still not the greatest at making these videos, so I don't know how to pause it right now. But just looking around my apartment, I can see some different examples just right around me in my oven mitt. So I can find two different types of lines in my oven mitt. If I'm looking for parallel lines, well, these two lines here, right here and right here, that would be parallel. So they would never touch. And then I can see perpendicular lines where the corners meet of this checkered pattern. We can see two lines crossing here. And then that would be perpendicular. So, I mean, that was just something within my sight that I could grab. That is an example of those types of lines. All right, so moving on. Your assignment is to complete 1 through 15. I'll pause the video here, or you can pause the video at home here in order to complete 1 through 6 by yourself. And then you can unpause because I'm going to go over 1 through 6 and fill them in. And then after that, you can do 7 through 15 independently. So starting with number 1, what geometric term could you use to describe the top and bottom edges of a book, and why? So let me, once again, grabbing the closest thing within my reach is my juicing book. So looking at the top and bottom edges of the book, here I'll zoom this out a little bit. So here's the top edge and the bottom edge right here. How would you describe those lines? Well, thinking about a book, did the top and bottom edges ever touch? No, they're not ever going to touch. So the top and bottom edges of the book we could describe as parallel lines. The top and bottom edges are parallel because the lines will never touch. And they go in the same direction. Kind of going into number 4 there. Let me zoom this in a little bit for you. Yeah, that's better. So the top and bottom edges are parallel because the lines will never touch and they go in the same direction. So that's really important because there could be lines that are never going to touch, but parallel, the other part of the definition is that the lines need to be going in the same direction. Here's another real-world example. What pair of lines look like the blades of an open pair of scissors, and why? So looking at a pair of scissors, if you open them up and you consider this part of the scissors as a line and this part of the scissors as another line, this is the point where they're going to intersect. So we could describe them as intersecting lines. Now, if you opened them like this, they would be a little bit more looking like perpendicular intersecting lines, but we'll describe them as intersecting. So we can say the scissors show intersecting lines because they cross at one point. Let's get this out of here. All right, so for numbers 3 through 6, we're going to use this diagram right here. Number 3 says to name 4 points. So we're going to look at the diagram. There are 4 points. There's W, X, Y, and Z. So in order for us to write those, when we're listing points, we just have to list the letter. So W, X, Y, and Z. Those are our 4 points. Our next one, number 4, we have to name 4 lines. So when you're naming lines, there's a certain way that you have to write it. You have to, first of all, we name a line by at least 2 points. So you need to find 2 points that are on the same line. So W and X would be a line, but you can't just write WX. You have to draw a little line on the top with the 2 arrows. So WX would be one line. There's another, if we look at this line here, it also shares point W and it has Y. So WY would be a line. We could call XZ a line. And YZ. Now we named 4 lines. We need to name 2 pairs of parallel lines. So 2 lines that are going to go on forever in the same direction and never touch. So first I see WY, and then even look, like lining up, if I lined up 2 of my pens, they would never touch going in this direction. So XZ would be a parallel line to WY. So we need 2 pairs. So that's pair 1. Make sure you're still drawing your little lines on top. So WY and XZ. And we need another pair. We could also call WX and YZ parallel lines. So WX and YZ. Now name 2 pairs of perpendicular lines. So perpendicular, going back to the definition, those are the lines that go on, or those are the lines that intersect to form right angles. So you need to be able to kind of draw a little square in the corner. So here, all of the intersections create perpendicular lines. So there's a few different that you can name here, a few different pairs. I'm just going to show you, like, you can draw a little square in the corner there. Down here, looking at number 12, just to show lines that intersect that are not perpendicular, you'll see the differences in 10 and 12, and which one you'll be able to draw the square corner into to show perpendicular. So back to number 6, 2 pairs of perpendicular lines. We could say WX and WY. And we could also use X All right, so I had some technical difficulties with my computer shutting down. So there's a few extra minutes at the end of this video. Bear with us as we're getting used to, remote teaching and using this technology. So you have to complete 7 through 15. Use geometric terms to describe what is shown. Be as specific as possible. So when you're completing, use the vocabulary definitions on the corresponding page over here to help you. And if you want, you can try some more on the back too, because I feel like this is probably just going to take you a few minutes. But that's all the assignment is for today. So thanks for watching. I hope everyone is staying safe and healthy at home. And we miss you. So I hope you miss us too. And have a good rest of your day.